formula and equations. So ionic charges. To study chemistry successfully at any level, you need to be able to write chemical formula and construct balanced chemical equations. In the topic, you will review how to write the formula of an ionic compound from ionic charges and how to balance chemical equations. Simple ions from the periodic table. You should remember from GCSE that many atoms lose or gain electrons to achieve the same electron structure as the nearest noble gas. So everyone wants to become the nearest noble gas. So hydrogen wants to, so not in the case of hydrogen, for something like which has a three atomic number. I don't know what that is. Hydrogen, helium, lithium.
Nitrogen.
No, lithium is the one that has three electrons. So it
Oh,
wants
wow.
to get rid of one of them so that it can be like a noble gas, which is helium. So
Yeah.
other than that, all of them, most of them want to have eight electrons in their outer shell, just like noble gases. So, okay, atoms of metals on the left of the periodic table lose electrons to form cations. Positive ions, you already know that. So all of the metals, they just lose electrons to form cations, which are positive ions, to become like one of the noble gases, to have the electrons as one of the noble gases. Atoms of non-metals on the right of the periodic table gain electrons to form anions. So you already know something like fluorine or chlorine, or the halides, or oxygen or sulfur
Yeah.
as shown here. For many elements, you can use the element position in the periodic table to work out the likely charge on the ion as shown in figure 1. So, um, yeah. So uh, based on looking at the periodic table, you can actually guess that if it is going to lose an electron or if it is going to gain an electron. It depends how close it is to which noble gas. So, for example, magnesium, it's easy for magnesium to lose two electrons to become just like neon, right? So, if it loses two electrons, it just becomes like neon. Uh, if based on their electronic configuration, obviously the protons will not be the same, but if it loses electron, its electronic configuration will be almost like neon because it will have the same number of electrons. And lithium, it loses an electron, so it becomes positive, so that it can become like helium. It is very difficult for lithium to gain electrons and become like neon. So what it does is it just loses one electron and becomes like helium. Does that make sense?
Wait, what do you mean? Why did you say it's difficult to gain an electron?
I'm saying it is difficult to gain electron because lithium has to gain how many electrons?
Oh,
Seven
seven,
electrons.
seven, seven.
And
Oh, yeah, yeah.
it is easier for it to lose one electron and become like helium than gaining seven electrons and becoming like neon. So that's why it's a bit easier by looking at the periodic table to guess what will happen with the how will an element react. Some metals, mostly transition metals, can form several ions with different charges. So for transition metals, it's common to form different kind of ions. Sometimes they lose two electrons, sometimes they lose three electrons. The ionic charge is then shown with a Roman numeral in the name of the ion. For example, cop copper forms two. So then it is shown like this. So copper forms two ions. Copper one, which is copper positive, and copper 2, which is copper 2 positive. So whenever you see this Roman numeral written with something, it actually
Yeah.
tells you what kind of ion it is. So if it is copper sulfate and it says copper 1 in the middle and then sulfate, when it is written like that in words, so you should know that it will be Cu 2 SO4 because SO4 wants two electrons and one Cu, it says one numeral, so it means that each can only give away one electron, so there will be two.
Yeah.
So just like that. And iron forms two ions, iron 2 and iron 3. So yeah, I think you understand. Binary compound. The binary compound contains two elements only. So any binary compound, why it is called a binary compound? Binary just means there are two things. So binary numbers are just 0 and 1. So binary just means two. So binary compound contains two elements. So it's obvious from the name.
Okay.
To name a binary compound, use the name of the first element but change the ending of the second element's name to ide. So to name a binding compound, use the name of the first element, but change the ending of the second element to ide. So we'll see an example here. For ionic compound, the metal ions always come first. So you say the metal first, then you say the uh, other part, which is the non-metal. So sodium and oxygen form sodium oxide. So you add IDE at the end of the second one, and you always write the metal at the start. So that is, I think that is fairly easy. Uh, Polyatomic ions. Sometimes an ion may contain atoms of more than one element bonded together. So atoms of more than one element. So the ions are called polyatomic ions. Table shows some common polyatomic ions and their names. Sometimes an ion may contain atoms of more than one. So now, if you remember, I used to call them radicals.
Yeah, yeah.
They have a name in your book as well. So they are called polyatomic ions. So
Okay.
polyatomic,
So it says that an ion that contains more than one element.
yeah.
So is a binary compound a polyatomic ion?
No, because it is not an ion. It has no
Oh,
charge.
yeah.
Yeah. So polyatomic ions have more than one element, and
Oh,
they
yeah,
also
yeah,
have a
yeah.
charge because ions are things that have charge. So
Okay.
I used to call them radicals because I think in my book it was radicals at one
Yeah.
time, but in your book it is called polyatomic ions. So they just tend to stay together, and we always consider them as one thing. So now they have a name as well, polyatomic ions. Like
Yeah.
NH4, so it's positive. OH, it's a negative. Carbonate, it's a CO3 2 minus. So uh, other examples are given. Writing formula from ions. An ionic compound contains a cation and an anion. The formula can be worked out from the charge on each ion. So you'll see. In a correct formula, the overall charge is zero, so the ionic charge must balance. So if you have a polyatomic ion like NH4 positive, and you want to combine it, let's say, I don't know if it is possible or not, but NH4 positive and you want to combine it with a phosphate, then there should be three ammonium, right? Three ammonium will be able to satisfy one phosphate.
Yeah. Yeah.
So they are talking about that because the overall charge should be balanced between the cation and the anion. Now ammonium is a cation and phosphate is an anion. So that's
Wait,
why.
so how would you write that? So
So
ammonium 3 phosphate.
if it exists, then we will write it.
Oh,
We will write it like this: NH4 C PO4. I think it
oh
exists.
yeah.
Yeah, it looks like I'm not making it up because I have heard of it, I guess. Ammonium. I think it's used in making fertilizers or something. Ammonium phosphate. So
Okay.
if you see there,
Oh yeah, yeah.
so it's just like how I have written it. So NH4 and then three and then a PO4.
Is it like a salt?
Um, I'm not sure if it's a salt or not. For a salt, it should be one metal combined with a non-metal, no?
Oh yeah, yeah.
So salt is
I
always,
think so, yeah.
yeah, I think it will not be a salt. So ammonium phosphate pH. So salt has a, how to know if something is a salt or solution of, it has a pH. So ammonium phosphate. Oh, it is a salt. So it looks
Oh
like
yeah.
does not need to be a metal. So ammonium phosphate is a salt of ammonia and phosphoric acid. All right, a chemical formula. Okay, so it is a salt, and it confuses me a little bit, but okay, so this is a salt. I always thought that salt should have a neutral pH. So is ammonium phosphate a neutral salt? The properties of ammonium phosphate are that it is a white crystalline solid that is soluble in water and has a slightly acidic pH. So
Oh
this,
yeah, because pH level was I think 4 point
yes,
something.
yes,
So
yes,
it's slightly acidic.
yeah, yeah. So it's slightly confusing, but look, let's hope that it's not in your course for now. So
Yeah.
let's just move on. But so far, the salts that we have seen are always metal salts. So they have,
Yeah.
then they have some kind of halogen or something else from the other side of the periodic table. So all right, so let's just move to the topic. So in a correct formula, the overall charge is zero, so the ionic charges must balance. Sum of positive charges is equal to sum of negative. You already know that. That's why we balance the ammonium phosphate like that. We had three ammonium,
Yeah.
one phosphate, so the charges should balance. Now they just show here how that's done. So I think I should be able to skip this one. So it says zinc chloride, for example, you have zinc and chlorine. So it we know that zinc is two positive and chlorine is just one negative charge. So we need so one zinc ion balances two chlorine ions because one chlorine is one negative charge and
Yeah. Yeah.
well, so we will need two of them. So that's why they have written zinc chloride like ZnCl2. So I'm just going to skip the other ones. You get the point, right?
Yes. Yes.
All right. So writing the formula, the number of each ion present is shown as a subscript after the ion. Okay. The ion charges are usually omitted in the completed formula. Brackets are used if there is more than one polyatomic ion. We have seen all of these examples in just the one that I wrote there, ammonium phosphate. So the number of each
Yeah.
ion present is shown as a subscript. So we always write, like if you have to say sodium sulfate, so we have to write Na2 in the subscript just to show that there are two sodiums. The ionic charges are usually omitted in the completed formula. We never write the charge again. Like we knew that ammonium is NH4 positive and phosphate is PO4 3 minus. But we never write that 3 minus or NH4 positive on the top. We just omit that when we write the formula.
What do you mean by you omit it?
Um, uh, like you know that ammonium, when we write it as an ion, we always write it as NH4 positive, right? But
Yeah.
when we write it as a compound, when it combines with
Oh yeah. Yeah. Yeah.
anion,
You don't write it.
yeah, we don't write it. Sorry, it's not two, it was three, I think. So yeah. So aluminium sulfate contains two aluminium 3 positive ions and three sulfate 2 negative ions. And so the formula is like this. Al2, because we need two aluminiums to give six electrons, whereas a sulfate each sulfate has gained two electrons, so we'll need three of them to counterbalance the six positive from aluminium. It's just
Yeah.
like they have taken the LCM of two and three, so that's six. So there must be six positives in total and six negatives. To do that, we have Al2 and SO4 3. Just
Yeah. Yeah.
yeah. Writing equations. You will have practiced balancing equations at GCSE. For A level chemistry, you will come across many more equations, but you will find that balancing them quickly becomes second nature. By the end of the course, you should be able to write equations for all the reactions you have studied and also for some unfamiliar reactions. All right. Representing elements and compounds in equations. In equations, elements are shown simply as their symbol, except for the few elements that exist as small molecules. Most of these elements exist as diatomic molecules containing two atoms bonded together. So molecules like H2, N2, O2, F2, Cl2, Br2, and I2. So these are diatomic molecules. They have two atoms in each molecule. The only
Yeah.
element that exists as small molecules are phosphorus and sulfur. However, it is normal practice to write sulfur simply as S in equations. Otherwise, every formula in the equation has to be multiplied up by a factor of 8. So it's S8 in nature, but they usually write it as S. So if you remember, we used to write the form. So it's kind of the same thing. If you remember, I don't know if I went through it with you or share. We write NaCl. I think I went through it.
Yeah. Yeah.
So we write NaCl, but we know that it's kind of a big crystal. It will have a lot of sodiums and a lot of chlorines in it. But we write the empirical formula. We just write
Yeah.
the
Yeah.
smallest unit that there could be if we just take
Oh
the
yeah. I remember we went through this.
yeah. So So why do we do that? Because in the equations we don't want to write Na million, Cl million. Obviously, we just want to write NaCl as simple as possible so that we don't have to multiply the other things with a million number or something.
Yeah.
So in the case of
Well,
S8,
so does S have to give away one electron?
why do you say that? These are not ions, by the way.
NaCl.
Oh, sorry. What was your question? NaC.
I mean, no, no, no. I was confused.
Yeah, yeah, yeah. So I'm talking about sulfur now.
Yeah, 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 yeah.
So it's kind
I
of
realized I got confused.
yeah, it's kind of the same thing. So and just like we write NaCl and don't write Na 1000 or Cl 1000 because that is not because if we try to balance the equation, we have to write that 1000, 2000, 3000 with everything. So
Yeah,
just try to make it as simple as possible. The same thing we do with sulfur as well. It's S8. It's not that big of a number, but we still want to write, we still want to minimize everything. So we usually write just S. However, it is normal practice to write sulfur simply as S in equations. Otherwise, every formula in the equation has to be multiplied up by a factor of it. So we just want to avoid that. So we just write S. Does that
yeah.
all right? So compounds. Covalent compounds do not contain ions. Most covalent compounds exist as molecules with a small number of atoms bonded together. For example, CO2 and H2O. So covalent compounds don't have ions because you know the things that have ions actually make ionic bonds and not covalent,
Yeah.
and they are ionic compounds. So these are covalent compounds. They do not contain ions. Most covalent compounds exist as molecules with a small number of atoms bonded together, for example, CO2 and H2O. In equations, the formula of the molecule is used. So in the equation, we just use this formula, CO2 and H or H2O or whatever.
But in A level, I think I learned this in school. They said that even in covalent bonds, there's still a little bit of ionic
Yeah,
bonding
yeah,
going on.
I think we also discussed it one time. I do remember. There is some polarity as well in covalent compounds because
Wait, what do you mean by polarity?
what was the wording that you were using? If you can repeat that. So
I'm not sure.
so what were you saying in A levels? You have learned what?
Oh, in A level, we learned that even in covalent bonds, there's some ionic bonding going on.
So what does ionic bonding mean? It means that the electrons are not fully shared. So one has more of a gain of electrons than the other one. Is that
Yeah,
what?
yeah.
Yeah. So that creates polarity. Polarity means uh, if something has a charge on it, like ionic compounds. Well, Na has a positive charge and Cl has a negative charge, right? So they
Yeah.
are polar in nature. Polar just means that they have a polarity. They have a charge. So one has a positive.
Okay.
So polarity just means that something, if something has a charge, we say that it has some polarity, positive polarity or negative.
Oh, actually, I think there's a word for this. I learned about it in school. I don't think it was polarity, it was something else. It was
Partial sharing of electrons,
polar covalent.
polar covalent bond. So
Yeah, yeah, so the ones that have the ionic and covalent is
yeah,
polar covalent bond.
yeah, yeah. So it comes from the same word, polarity. So they have a
Yeah.
polarity. That's why they're called polar covalent bonds because they make poles. Like a, oh, my geography is not that good. So we have two poles, right? North Pole and South.
Oh, oh yeah.
That's correct. So so both of them are called poles because they have different polarity. So same is the case with positive charge.
Oh,
So they have different polarities. So polar covalent bond just means that one of them is partially has a positive charge, the other one has a negative charge. Now, if something is so you know H2. H2 is also a single covalent bond in between, right?
yeah.
But there is no polarity in it. Why? Because it's not a polar covalent bond because both of them have the equal tendency of sharing or pulling, sorry, yeah, both have the equal tendency of pulling the electrons towards them, right? But if
Yeah.
something is like, I'm not sure if this will be the correct example, but if something like water, then obviously maybe I think oxygen will have more tendency to gain the electron than hydrogen. So there will be when I write this just means partial. So there will be partial positive charge
Oh,
on
is that
hydrogen.
delta?
Yes, yes, yes. So there will
Yeah.
be a partial positive charge on hydrogen and a partial. So it's not that it's completely ionic compound. It's just that the electrons that are being shared, you can say that they are closer to oxygen because oxygen has more tendency to keep them with it. So same is the case. The shared electrons will be more closer to oxygen than they are to hydrogen. So we will say that these are polar covalent bonds that are in that are in water because both of them are not the same, right? Like hydrogen, oxygen are different. Oxygen has a different kind of nuclear power, or sorry, nuclear power will not be maybe the right word, but it will have more attraction because of its nuclear energy or the energy from the nucleus because it has more positive charge, right? So it has
Yeah, yeah.
more positive charge, so it will have tendency to attract electrons more than hydrogen because hydrogen just has one proton in it,
Yeah.
right? So that is called a polar covalent bond. It's a covalent bond, but the thing is that the shared electrons are, you can say they are slightly closer to one of those elements. And that's why
Yeah, yeah.
they create a partial polarity or partial charge on it, right? Okay. So, okay. So, yeah. So, for ionic compound, the formula worked out from the ionic charges is used in equation. This is called the formula unit. Okay. For ionic compound, the formula worked out from the ionic charges is used in equation. This is called the formula unit. Why it is called a formula unit? So, so why do we have to name it specifically the chemical equation or the chemical formula? Why do we need to say formula unit like for example NaCl, or if there is another one like I don't know, copper sulfate is also maybe, sorry, copper sulfate, is copper two positive or just one positive? I think there are two kinds of copper as well.
Yeah. One that gives 2 electrons and one that gives three.
Yeah, yeah. Oh, two and three. So I think I have it wrong. So it will be CuSO4. Okay. So the things that have ionic compound bonds in them, they usually form big lattices or big crystals. So we always have to use the empirical formula just to bring them to their smallest unit. And that's why
Yeah.
they had to name it differently. And they said that this is called a formula unit. So the chemical equation or the chemical formula we write for the ionic compound, it's also called a formula unit because it's a unit. It's the smallest unit that there is. So we just say it's a formula unit. Does that make sense?
Yes,
The
yes.
other ones are just called oh, sorry, what are they called? They are just called chemical formula. And this one is called a formula unit because of this reason. State symbols in chemical equations. I think you already know about the state symbols, or if it's
Oh, yeah, yeah.
liquid, solid, aqueous. So if it is dissolved in water, I think
Oh,
you,
so you said that the ionic compounds always form a lattice.
yeah.
Yeah. So, is this the giant 3D ionic crystal lattice?
So I don't,
So in GCSE, I think we just used to call it a lattice.
yes, yes. So I think it's, sorry, which one did you say it is?
Giant ionic 3D crystal lattice.
I don't know if all of them come into this category, but I think most of the ionic compounds they usually form big crystals or lattices. When I say lattice, I just mean it's a mesh of structure that they form, just like sodium chloride.
Oh
So
yeah, yeah.
yeah, so we have to take the smallest unit out of it, which is called a formula unit. The one that you are talking about may be a subcategory of that, so I'm not completely sure what it is.
Okay.
If it comes up, we'll just see what it is. So Balancing equation. To balance an equation, you multiply each formula by a balancing number until the number of atoms of each element is the same on each side of the equation. Balancing numbers are written in front of each formula. 2 sodium oxide means 2 sodium oxide formula units giving 2 times 2. So I think this you already know. So there will be
Yeah, yeah, yeah.
right. So write a balancing equation. You must not change any chemical formula. Balancing numbers go in front of chemical formula and on the line, not subscripted. You already know this. This equation is balanced when there are the same number of atoms of each element on each side. I think you already know all of this.
Yeah.
So should we go through this example?
Constructing a bunny. Is it the same way as GCSE?
Yes, I think so. They just write okay, so first of all, they figure out what kind of compound it is going to make. So they know that aluminium and oxygen are going to react to form aluminium oxide. How do you know aluminium oxide will have how many atoms of aluminium and how many atoms of oxygen? This you know by looking at their ionic structure. So aluminium, you know that it can give away 3 electrons and each oxygen can take 2 electrons. So you take the LCM, sorry, yeah, you take the LCM and that comes out to be 6. So aluminium has to give away 6 and oxygen has to gain 6. So for that, we need 2 aluminiums and 3 oxygen. So that's why we first know that it will make Al2O3. Does that make sense?
Yeah.
And we know that for all the metals, we just write it as a single unit. So we just write Al, aluminium,
Yeah, yeah.
and O2 is how oxygen is in nature. So Al plus O2. And then I think you already know how to balance. So if there is 1 aluminium on left and there are 2 aluminiums on the right.
Yeah.
So what I'll do is I'll first write 2 aluminium. So 2 aluminium, but the thing is that we have 3 oxygen here. So eventually we'll figure out that we need to multiply this by 2 aluminium oxide so that we have 4 aluminium that react with 3O2. So three
Yeah.
the oxygen molecule. So I think you can figure that out yourself.
Yeah,
That's
that's
not
fine.
very difficult. Okay, balancing formula with brackets. Take care. Okay. Take care when balancing formula with brackets. Remember that balancing number multiplies. I think you already know this. So for example, zinc nitrate. So this 3 that is written here, first of all, this 2 that is outside will be multiplied with everything inside. So this 3 zinc nitrate actually has um, 6 nitrogen atoms and 18 oxygen atoms. Does that make sense?
Yeah.
Yeah. Then it's fine.
We,
Oh,
so it's 6 oxygen, but then it's the nitrate is also oxygen. So is the subscript for the nitrate also affecting the number of oxygens?
yes, yes. So
Yeah.
this 2 will be multiplied with both of them because this just means there are 2 nitrates. All right. So did you understand why we have 18 oxygen atoms in zinc
Yeah,
nitrate?
yeah, I understand this.
Right, let's just move forward then. I think you can go through these questions if
So
you
if
want
there
to.
was like a question saying that how many oxygens are there,
Yeah.
will I say 3 or will I say, wait,
If someone asks you how many oxygens are there
or will I say 6?
in in 3 ZNO
Oh,
ZnNO32,
so
so
is it
you will
9
say
or
18.
18?
Then it will be 18.
Okay.
So if someone says how many oxygen are in this thing, then you will say
Yeah.
18. But if someone says how many oxygen are in zinc nitrate, then you'll say 6.
Oh, yeah, yeah.
Yeah. All right.